Good evening, folks. Welcome to vBrownBag, the weekly IT video podcast where we talk about all things IT. Tonight, we've got Marino on deck, and we are going to be continuing the Certified Kubernetes Administration Study Series, helping you to get ready for the CKA exam. This evening, this is actually going to be a twofer. This evening is part one of networking, and then not next week, but the week after, we are going to continue with part two of networking. There's a little time gap scheduling, calendaring, shimmy, shim, shake that we had to do. But if you are watching this after the fact on the YouTubes, then you can watch them in order. Those of us live in the studio audience, we can ask all the questions that we want. I will be filtering for the peanut gallery tonight. I don't know why people come up with me, but I'm going to be doing it. So if you want to get in on the conversation, you know what? I messed up my own cadence. Okay, hold on. Everything that I just said, think about that and then look at the screen and you'll see that there's the episodes in order. Like I said, we're going to do storage next week, but then we're going to do episode 6 after that on the week after that. So with that, now get in on the conversation. If you at vBrownBag or hashtag vBrownBag, I will be paying attention on Twitter. If you are in the live studio audience and you want to ask us some questions, feel free to hit us up either in the chat or the Q&A. I will be paying attention. Marino will be doing his standard fabulous job of the presentation. He has blown past me in the beard section and the hair section this evening. I am truly, truly upset. It's been, I can't even grow a ponytail anymore. After a certain age, it started getting thinner up there, and I was like, I don't want to be that bald guy with that comic book collector ponytail on the back. That's just wrong. So our friend Marino Wijay, if you want to follow him, and I highly encourage that you do on Twitter, you can follow him at virtualized6ix on Twitter. I got that right?
Oh yeah.
All right, cool. Is that from when you got your VCIX for VCAP 6 or what was that?
It was a little bit of a combination of me just kind of jumping into VMware and kind of tying it to where I'm from, Toronto. Toronto represents the 6. That's why there's the 6ix in there.
Oh, okay.
But the virtualized is like that play on, VMware and the whole virtualization aspect. I should probably update that at some point, considering where I am. But anyways.
Don't worry about it. It's all good. Oh, well, actually, that's right. You recently made an announcement. Is that something that you want? Can you talk about you leaving and where you're at now and what's going on?
Oh, yeah. So I can talk a little bit about it, not too much, but I've been at VMware for about 4.5 years now, and I decided to leave and pursue some interesting opportunities externally. So my last day is October 15th. It's kind of interesting because the V community has been like a huge part of my life, even before joining VMware, and to see it flourish and grow and to see all the different personalities out here providing so much amazing guidance and learning and teachings. It's wonderful. Like I honestly wouldn't have grown without the V community, in my opinion. But yeah, I'm excited to be here.
Awesome. And are you keeping your destination under your hat for now? Is that still on the down low? Okay.
I am. But one thing I will share is that I think VMware helped me pivot towards a little bit more of the cloud native space. So what's interesting is the role that I will be taking on will be focused in the cloud native space, much more so than the V community. And it's a rather interesting move because I kind of believe in certain technologies and where they're going, what they're aiming to do, and the problems they're aiming to solve. And I only think they can get better. But I'll share that probably in our next session and give you some more details as to where I'm actually going.
Awesome. And if you are going to a cloudy destination, then obviously we'll be seeing a lot more of you in that regards as well.
Interestingly enough, it is not a cloudy destination. So.
Oh, okay. Well, we'll keep it under our hat until then. All right. So back to the topic at hand: Kubernetes, K8s, the stuffs, the networking, the sexiness. Let's bring it on.
All right, let's go.
You have the power, sir.
I have the power. Can you see my screen? Can you see something at least?
You started screen sharing. There we go. All right, I can see it. You're in.
Excellent, excellent. So I am not going to do presentation mode because I hate animations. So I also try not to use decks as much as I can. So I'll try to be a little bit hands-on, but I feel like I need to get some fundamentals out of the way because I'm not too sure where everyone is at in the audience in terms of their level and experience with Kubernetes or just networking in general. But let me just briefly start and introduce myself or reintroduce myself. So for everyone, I'm Marino Wijay. You can find me on Twitter and LinkedIn. I love a whole variety of different kinds of foods. I actually love cooking too. I don't put that up there, and I don't often publish that I cook, but when I do, I'll just kind of post some pictures here and there. But what I'm really here to talk about is Kubernetes networking and why it's important, specifically in the context of the CKA or the Certified Kubernetes Administrator exam. I did the exam about a year and a half ago, and so the exam has changed, obviously, version wise, as well as the number of questions and how long you have. So when I did it, I had 3 hours to write the exam, which is definitely a little bit more time, but they had more questions and it felt equally as hard. One of the interesting things about networking in the world of Kubernetes is that it's meant to be easy when it comes to setting it all up, but you have so much flexibility in what you can do when it comes to container networking. And what I mean by that is you have the flexibility of essentially saying certain containers and pods and whatever else can communicate with others while others cannot. You're basically writing networking for your container workloads. But what is also really interesting is what Kubernetes has done is it has made networking so necessary, but at the same time, less than the complication doesn't need to be there. So as long as there's connectivity, then Kubernetes will work. I mean, there's some more to it, but I'll get into that shortly. I'll cover off the blueprint very quickly because I just want to review it and make sure we level set where we are. I'm just going to cover off some brief networking things in the context of the CKA. I want to talk a little bit about networking in the context of clusters and the kind of networking that supports these clusters that run our container workloads. We also need to know how containers communicate with each other and certain patterns that we may see. And then there's also an interesting technology or a set of technologies we need to look into called the CNI, or the Container Networking Interface, which is, if you're familiar with the world of virtualization, which I'm sure all of you are, if you think of a vSwitch, it's kind of the same concept, what a CNI is, or a container networking interface is, but I'll get into a little bit more details of what it aims to provide. If we have time, I'm sure we will, but I'll cover off services as well. Services are just a way to allow your app that's deployed onto Kubernetes to be exposed externally. So far, I'm going to make the assumption that you all are familiar with Kubernetes because you've been following the CKA series so far, and at a high level how things work inside of Kubernetes. You know how the components work, and you're familiar with the overall architecture. If there are any questions about just architecture, let me know. I'll try to explain it to the best of my ability. So quickly, let's review this blueprint. So on the exam, you're going to see some storage stuff. So I'm not sure, I think it's next week, if I'm not mistaken, or the week after. But effectively, that's really all about persistent volumes, volume claims, and how you assign storage so that pods can access it. There's going to be some more details around, how you, I guess, mount volumes to pods and certain things like deployments. The troubleshooting section is rather interesting. It's changed because it was a lot, I guess, smaller in the last exam, or the exam that I did. So I feel like there's going to be a lot more of, hey, things are broken, your kube config file is broken, or your kube proxy is not set up properly, or something to that effect, or maybe kubelet has a missing config and maybe you have to go troubleshoot those things. I would also guess that there might be some network troubleshooting involved, and so I'll provide some some just general tips and guidance as to how you would go about with network troubleshooting. I know you're going to be covering workload scheduling, or you might have already done that a while back, and that's really all about scheduling your pods, your container workloads onto nodes, and how you can manipulate that in a variety of different ways. I think 2 weeks ago or last week, Nathan covered off the cluster architecture and installation. So so that was, I actually had to review some of that earlier this morning because I decided to go build out my own cluster manually all over again. And it's been a while. It's like these days, I mean, unless you're picking up Kubernetes for learning, you're not going to be sitting there building out every single cluster that you're going to use. You're probably going to use some service like EKS or GKE from AWS and GCP. Now, the area that we're going to be focusing on today, services and networking, and more primarily how traffic flows within a Kubernetes environment and how different, I guess, containers communicate with other containers, as well as communication outbound and towards resources from external locations. So we're going to cover off like how to handle node networking, understand where the CNI comes into the mix with respect to pods, and then understand the different types of services that are used to expose these different applications. There's an interesting bit around services and why they exist and what they're really here to do. And it's really all about abstraction, because in the world of cloud native, we like to treat things as things that can immediately disappear or die off at any time, and something else will come back and take over, right? But the underlying networking should always be there and should always continue to respond. And I'll talk a little bit more about what that means. In the next session, I'm actually going to dive into the ingress controllers and ingress resources, because it's a little bit more of an advanced topic of how to route towards an appropriate backend inside of, an application that you have. And it's a little bit more of an involved conversation. And we'll also branch off into talking about what core DNS does and a little bit more about how we can manipulate it. When I did my exam, I don't recall having any sort of core DNS related questions, meaning I didn't have to interact with it, log into the pod, or sorry, I should really say exec into the pod and manipulate anything. I think more than anything, I was just having to do some sort of lookups and just making sure that core DNS was functioning. And I'll talk a little bit about what that also means. So, all right. It's not DNS, but it always is DNS. But in reality, I mean, the reason why DNS might not be available is because we can't get to it. And, as is the case with Facebook and the recent outage that they experienced, it's interesting because, while a lot of things pointed to DNS, I mean, if you can't get to DNS, it's probably a routing issue. And why I bring that up is because in the real world, when you're deploying and working with Kubernetes clusters, you're going to be dealing with a lot of networking. You're going to be dealing with a lot of routing. You're going to run into DNS related issues. But one of the things that is really nice and clean about Kubernetes is the way it handles internal DNS. I'll talk about that shortly. Now, just to give you all a primer on networking, right? Some of the things that we care about with respect to the CKA is we're working with a bunch of virtual machines. They're Linux nodes, and they're going to have some form of layer 2 or layer 3 communication to each other. And so some of the things that we need to be, at least concerned about or mindful about is, can we route to certain objects or certain endpoints inside of an environment? And if we can't, why not, right? Is it because we're missing a gateway? Is the gateway just not reachable? Is it down? Maybe our subnet mask is off, which means our gateway is actually in a different subnet when it's supposed to be in ours, right? And that could lead to a variety of different issues, which could cause a cluster to not function or not produce the results you're expecting. And so that ties to gateways, right? Making sure that all nodes have the right gateways, because the other thing to consider is that when you're working with clusters, maybe you're not pulling workloads or you're not pulling container images from public repositories, but you are locally. They may not be located on the same subnet. And so you might need to hop to another subnet via that gateway to get those container images. But that's just another thing to consider. There's a very rare case where you would actually have like Kubernetes nodes of a cluster in different subnets. I mean, it's entirely possible, but one of the things to consider is like latency. If you decide that, hey, I want to basically distribute 3 nodes of a cluster in 3 different subnets, you're adding latency into the overall hop in order for all of those nodes to communicate. So it's something to consider when you're building out a cluster. Most of the clusters that you might build out, whether it be something like with vSphere Tanzu, or I should really say Tanzu Kubernetes Grid, or something like EKS, a lot of the times the networking is automated, so you don't really have to worry about whether or not nodes can communicate with each other. They're more than likely going to be on the same layer 2 network, and they're going to have a gateway that they can get out to. I did bring up subnetting. Subnetting is important because think of it from a troubleshooting mindset. If you go into an exam and you're trying to troubleshoot why a node can't communicate with the control plane as a part of that cluster, it could be as simple as the subnet mask is off and it's just in the wrong subnet. So maybe you might have to go manipulate the Ethernet interface on that Linux box so that you can just change the subnet ID, or I should really say subnet mask, so it falls in the right range or falls in the right network. That's just an example. I'm not saying that it actually isn't on the exam. I don't even know for sure it is. For some reason, I remember seeing something very similar to that on an exam. I don't know which exam, but it's always one of those gotchas. I'm sure that they'll throw it in there. They expect you to know how networking works. And DNS. DNS is definitely one of those important things. I bring this up because on the exam, let's just say you had to do a cluster installation, much like you did with Nathan a few episodes ago. Most of the time, your binaries are not going to be located locally on those Linux boxes, and you might need to download them from somewhere. If you want to download them from somewhere, they might be from a public repository. So you're basically pulling things like Docker or Containerd from a public repo, in addition to things like kubeadm, kubelet, and kubectl. But if for whatever reason those nodes don't have access to DNS, they can't get out to the internet. So you may have installation issues or bootstrap issues. So in those situations, maybe it might be a situation where one of your nodes just can't communicate out to the internet to pull down those bits, and it might be just because it doesn't have the right DNS server set up or something like that. And this is just another thing to consider when it comes to networking. The exam itself assumes that you know how a lot of these concepts work. And I honestly can't come here and talk about networking. We could spend like 5 hours just on the OSI layer if I wanted to, but it's one of those subtly important things that you need to understand. I would say just familiarize yourself with layer 2, layer 3, and how routing works. And I'll cover a little bit more of this as I go along. So let's start with
one quick question.
Sure, yeah.
Oh, it was just a fast one. Is it all V4, or is there any IPv6 in the exam that you know of?
So as far as I understand, the exam doesn't bring up IPv6. I think for a variety of reasons, it's just too complicated to have to sit there and calculate any sort of IPs, and some other bits and pieces. But the other thing too is, as far as I remember, I think it's still in beta, dual stacking at the moment. So, gotcha. And that could be for the host networking in addition to like container networking. So it may not be fully supported, and that's chances are it's probably not going to be on the exam. One of the things I would recommend, just to be sure of that, is if you actually follow killer.sh, or if you follow Mumshad's CKA course, he'll actually have some bits on whether or not IPv6 will be in there. And even in the blueprint, I don't recall ever seeing anything around IPv6, so I wouldn't really worry too much about it. I never had it. Doesn't hurt to look into it though. So when it comes to just host networking, right, we really just want to ensure some key things. Can the hosts communicate with each other? And this is like as simple as you are logged into a Linux box, whether it's Ubuntu or Debian or whatever your flavor of Linux is, and you're just looking to ping your peer host. Does it respond? Okay, it responds. can you SSH to it? And if you can SSH to it, that means that your firewall on those nodes are probably open. So they're allowing all ports, which means you're probably going to see a lot more communication go through without any issue. You also want to check in and see you have internet reachability, and maybe you want to curl like google.com, for example, just to see if it provides a response. In the situation that your nodes are on different networks, I think it's ideal to look into the fact that they can route to each other, and if they can't, it might warrant the need for a static route. One thing I need to point out is in most production deployments that you're going to find with Kubernetes, and with a Kubernetes cluster, you obviously will have a control plane and a data plane. But in your control plane, we like to implement load balancing or high availability, and we'll do so with a load balancer. So when you go out to, let's say, bootstrap a Kubernetes cluster with kubeadm, there is actually a flag called the control plane endpoint. That control plane endpoint actually maps to something which is actually the DNS name you would use to access that Kubernetes cluster. So let's just say you went into your DNS server, created an A record for that cluster that you would access and use kubectl against. That control plane endpoint is there to allow you to then bootstrap a secondary control plane node and then stick those control plane nodes behind a load balancer. So I just bring this up because if you are working in the real world, you will likely encounter this. A lot of it's automated, but on the exam, you will never have to worry about this. They're not going to ask you to run kubeadm in it with that control plane endpoint flag, because the exam environment is limited in that you can't simply just use a load balancer or a public load balancer. So they take away certain things. It's just something for you to be aware of as you're going into production or you're working with it long term. All right, so let's move on to pod communications. Just checking the time here. So we're good for time. I'm going to move through these rather quickly so that we can get to the hands-on stuff. But for the pod communication, it's really about can your containers, when they've been scheduled in Kubernetes as pods, communicate with each other. Now, let's be clear about something. If you have a pod and you actually replicate the number of copies of that pod, and you say have 3 copies of it, we're not trying to ensure that these 3 copies can communicate with each other. And the reason for that is because they act as independent entities that are servicing all the incoming requests. So they're sharing the load of those requests that are coming in, but they never really need to communicate with each other. There are other situations where pods need to communicate with each other. For example, you have an application that needs to communicate with a database pod, or you have a pod that you write logs to, and that's your pod that you would reference down the line. Now, in order to interact with them, there needs to be a network, but the way that they interact is a little different. And I'll get to that when we talk about services. But what ensures that pods can communicate is having something called a container networking interface. Now, when you went through the installation or the bootstrap of a Kubernetes cluster a couple of sessions ago, you might have encountered a step that once you've run kubeadm init and your cluster is kind of pseudo online, there's one part where it says core DNS hasn't come online yet, or the pods aren't running for core DNS. And this is because there's no CNI available. What's interesting is all the other pods that are scheduled are actually pods that are scheduled either on the control plane node or the worker node locally. But they're also using local hosts to be able to communicate with services and the underlying network adapters. But in the case of pods that you spin up, they won't be using local hosts to be able to get outbound. They need something else. They need a container networking interface. So does core DNS. Once core DNS is stood up, then everything else will continue to function, and then lookups can occur like normal. But effectively, core DNS is internalized DNS. Now, the CNI itself on the exam, if you're having to bootstrap a cluster, I actually have found a link that you can bookmark, which actually has an example to a CNI, but I'll talk about that in a second. Once you deploy the CNI, once it's active, your pods will start getting IPs once they are scheduled, and then they'll be able to communicate with the kube proxy. And we'll talk about the kube proxy momentarily. Now Now, what is a CNI? So a CNI is meant to be a networking layer for your pods to communicate either inbound or outbound or to each other or to the kube proxy. It's almost like this logical switch that lives inside of Kubernetes, which all pods will attach to, will have an interface off of. And so there are a variety of different CNIs out there. VMware has their own CNI called Antrea. You might be familiar with the CNI called Calico. There are other CNIs called Weave, as well as Cilium. Cilium uses a technology called eBPF, which allows you to write interesting and a variety of different programs in the kernel. And that's why that CNI in itself is a very interesting technology altogether. But pretty much any CNI will do what you need for the sake of running Kubernetes. They all have similarities in terms of the capabilities that they offer. For example, a CNI will offer networking so that you'll always get an IP. It might offer IP address management. It may offer network policy. So network policy is allowing you to control the flow of traffic from one pod to another, or a set of pods to another set of pods. A CNI might have the ability to turn on routing protocols like BGP, for example. So you can turn your pods into BGP speakers if you want to. And this might be in a situation where you're looking to not run an overlay between your nodes, and you need like just layer 3 to handle a lot of your node and your pod networking and your pod-to-pod communication. But CNIs are effectively just that. They're the layer in which your pods now can communicate. It's like you take a bunch of virtual machines and you plug it into a switch or a vSwitch in vSphere. So one thing I will point out is this link right here. If you're going to take the CKA exam, go bookmark this right now. The reason why I want you to bookmark this is because I'm going to reshare my screen and take you to the site that, hold on a second. That's not it. Where's my Chrome? There it is. Okay. Okay, can you see this?
Yes, we can see your screen.
Okay, perfect. Okay, so if you pop that link open, it takes you to this website or this section of the documentation. So I'll actually just reopen it and tell you where it takes you.
Can you drop that link in the chat channel for everybody?
Oh yeah, for sure. Let's do that. Okay, it is small. So let me just make it a little bit bigger. Okay, so once you open that link, it takes you right here. All you need to do is just scroll up a little bit, and the link to install a CNI is right here. So what's interesting is the exam either expects you to memorize a CNI installation or just not pass that question, which is kind of hard and unfair, right? But the other way to think about it is, I think it's intentional that they want you to read the documentation, because if you're actually reading the documentation before you go write the exam, you will catch this. You will definitely find this out, and that you'll actually have an example to use for the exam. Now, like the exam itself, they say you could basically do it any way you want. If you've memorized how to deploy Calico, all the power to you. But if for whatever reason you just can't remember the URL, well, here's your bookmark, save it, come and reference this when you're writing your exam. And I say that this is important because if you don't have your CNI, Core DNS will not work, which will likely mean that you cannot schedule pods, which likely means that the question or a subset of questions probably won't allow you to pass because you don't have your CNI. So this is important. It's one command. Once you run it, run the command right afterwards, which allows you to just verify that the Weave operators or Weave agents are up and online, and your Weave CNI is running. But once you do have your CNI up and running, there's a few ways that you can go and verify that. If you just type in ls, and I'll show you this in the terminal, if you type in ls and then this path, it'll actually point you to some information around the different CNIs that exist inside of the node. And then this one right here will just, when you actually run this with ls, it'll actually spit out a file. And then if you cat that file, it actually tells you details about the CNI as well as things like any sort of IP address management setup you have in there. The CNI is one critical component of it. But what I will say is, I don't think there's going to be a lot you'll have to do with respect to the CNI. It's really just making sure that you can deploy it and your pods will get IPs and get scheduled. I'll actually show you what that means if you don't have a CNI shortly. So what I'm going to do is I'm going to quickly pause the presentation. I'm going to hold on a second. I'm actually going to flip to the hands-on for one part of this so that we can cover some of the CNI bits and pieces, because I think that's important. And then we'll get back into talking about services and understanding what goes on there. So in the meantime, are there any questions about container networking interfaces and how they operate? I will add that there's so much more to CNIs and how they came to be. And it has a lot to do with things like network namespaces, but for the purposes of the exam, it's not something you need to worry about too much.
I am scouring the Q&As in the chats, and we are clean for questions, sir.
Excellent, excellent. Okay, let me just get one of my terminals up here.
Some beard care related questions, but nothing relevant.
No open question. All right, let's go. Let me okay, so actually, let me just do this too. So I actually have an environment. I have two environments actually. I decided to turn up I don't know what happened there. Turn up a Kubernetes cluster manually, and I also created something called a GKE cluster. So the GKE cluster is a managed service. Basically, you log into Google, or you can log into any cloud provider. I'm sure you'll find an equivalent service. And you say, hey, I want a Kubernetes cluster with this name. And you click next, 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 and there you have a Kubernetes cluster. But what's important about that is, because it's a managed service, you have access to be able to deploy applications, but you don't have access to be able to manipulate the control plane. And that can be good depending on what you're trying to do. I mean, if all you're trying to do is run some applications, then a managed service is perfect. But if you need customization, if you're trying to create some custom resource definitions and then build your own operators to do some very interesting things in your cluster, then chances are using a managed service might not be for you. And you may need to do it yourself and use some of the tools out there and build maybe a sustainable practice around your clusters that you build out. All right, so what I have here, like I said, is I have a single Google Cloud virtual machine instance. It's a standard, I don't know what type, it's some generic machine type with 2 vCPUs and 4 gigs of RAM. That's really all you need. You need like 3 of these and you're good to go. But what I did was I just went ahead and I bootstrapped Kubernetes by downloading all the bits. I actually followed Nathan's video from the last session, just to kind of make sure that I had at least a working cluster. So I can even show you, if I run kubectl get nodes, there is my cluster with 2 nodes. I've got a control plane node as well as a worker node. And if I do an O-wide, I can see some more details around, let's say, the version of Kubernetes that's running. Now, I know that the version that I'm running is 1.22. The version on the exam is 1.21 for the CKA. The differences in terms of like what you're going to do, like for the version itself, very minimal. Like if anything, they've just deprecated certain functions and they've moved things from beta to the mainstream API backends. So, you know, what I want,
Marino,
yeah.
when we're in text, can you make the fonts larger or go?
Oh yeah, sure. Let me see.
The text is super tiny.
Sure. Let me just adjust this here.
Make it bigger.
Is that better?
Yep.
Much better, or?
Yeah, better. when you were on single screen, it was working really well, but I see why you need to go split screen.
Is that better now? I can stop sharing the other one for a minute. There we go. I'll just do
audience. What do you think?
I can come back to that later on.
There you go. Okay, cool.
I don't really need the other screen right now. Okay, cool. Okay, so let me just rerun that command again. And just for being able to read it, oops. Basically, your two control plane and worker nodes right here in one cluster. So just so that we're all familiar, right? I mean, I'm sure all of you know these commands, but we always want to make sure that we can ping, right? Ping, and I'm on the control plane node right now, so I'm just going to ping the worker node, and I can verify that it works. But you also want to make sure that your DNS is functioning too. So if I did, NS lookup 10.128.0.24, it should resolve to CKA worker 2, and it actually does. So I'm good there. But if you want more details, right, there's also the dig command. So the dig command will give you some more specifics. It will tell you multiple pointers that might exist behind that A record there. And so if I did, CKA worker 02 dig, it just tells me, did I miss something? No, just tells me some details about it. Wait, is that even right? Maybe I'll try it this way. 10.128.0.24. Ooh, dig's not working for some reason. Got to insert. Huh, okay, interesting. So what dig is supposed to return? Oh, no, it did right here. Oh, no, it didn't. Okay. What dig is supposed to return is the, if you give it an IP, it'll return the host name, vice versa, but I don't know why it's not working here. It was earlier. Anyways, it's another tool that can be handy on the exam if for whatever reason name resolution isn't working. You all are probably all familiar with ifconfig, not ifconfig, but there's also something called IP link, which actually summarizes the different links that are available out there. And then a few other commands you just might want to be familiar with are like the route command, so you can know if you have a gateway that's there or if you have any sort of other routes to other destinations on that node itself. It's super rare that you would have a manual static route on a Linux host, but I've seen it before for a variety of different reasons. Gateway just can't be accessible or can't do certain things for us. Outside of that, the only other thing I'd say that you want to be familiar with is the host file. The host file is like your localized DNS record. If for whatever reason, the host file has an entry in it for, let's say, a particular destination, either the IP or the host name, that will override any DNS server that you have set up here. So that can be problematic, even from a troubleshooting standpoint. Let's take, for example, you're on the exam, for whatever reason, you can't run kubectl init join, or sorry, kubectl join with the host name. And then you're like, why can't I do this? Why can't I resolve it? Or why can't I, join the cluster? Some errors might be spit out, and maybe the error might say, cannot resolve this host name. That might be an indicator that something is wrong with DNS. Can you ping that host name? If you can't ping that host name, is DNS even present on the host? Like, is there a DNS server that's going to resolve on the host? If not, is there something in the host file that's preventing you from accessing that control plane node? So knowing these little things inside of your Linux operating system is definitely going to help you for the exam itself. Are there any other questions here? Is it safe to say a good understanding of Linux networking troubleshooting would then translate to the exam? I would say it's valuable. If you are familiar with navigating Linux networking, it'll be very powerful for you on this exam. I will come out and say I am not a Linux expert. I may be a 5 or 6 out of 10 when it comes to Linux, maybe even 4 out of 10. But the exam is not a Linux exam. It's a Kubernetes exam. And I think it's just a matter of knowing the tips and tricks that you would use in Linux to manipulate Kubernetes to your benefit and to your advantage on that exam. So the tools that I shared, be familiar with those, and I think you'll be fine. Okay, so we covered off that. I want to just quickly cover off something with respect to the CNI. So earlier on, I deployed the CNI here, and we can see that I deployed a CNI by verifying something here. So if I just clear my screen, and if I did a kubectl, I can't see my screen here. Okay, a kubectl get nodes -a. The -a flag, if you're not familiar, oops, sorry, not nodes, get pods -a. The -a flag just enumerates all the pods and all the namespaces. So the moment I do that, I'll know that I've got an Nginx pod in the default namespace. And then I've got these two Weave pods as well. These are the Weave agents that are servicing my CNI. Now, I deployed this earlier on, and I just need to make sure that it was working. I definitely do have the command somewhere up here. Okay, so this is the command that you would likely want to use. And like I said, I've already shared it, bookmark that link. And by the way, that link and that bookmark will be available to you on the exam. You're allowed to have the Kubernetes documentation as a reminder. So again, it will come in handy. The moment I hit this, it will delete my Weave pod. So when I go back here, it's going to terminate, and it may look like, you know, everything is running. In fact, all of these existing pods will run. Core DNS will function based off of its current last known good state, and same with Nginx. But there's actually no networking layer, so none of these things can communicate with each other. Now, what's interesting is if I go ahead to try and run a different kind of pod, so kubectl run busybox --image equals busybox, a different kind of image, right? If I do a kubectl get pods, I'm just going to enumerate the pods inside of my namespace, the default one. So it's saying container creating, right? And I'm just going to append the watch here just so that we can see if it changes. And I'm going to set the timer for 10 seconds, and that should change in the next 10 seconds. But I don't think it will. And I'm going to show you why it won't. All right, that is 10 seconds. So what I'm going to do is I'll just do it again, get pods just to show you again. So nothing changed. We're going to describe the pod, kubectl describe pod busybox. Now, I know y'all are thinking like, you know, why doesn't this guy use aliases and whatnot? You are welcome to use aliases. It's a preference. I felt like it took up more time to create the aliases that I needed and then to remember them and then to go use them. If you've got a pattern that you're familiar with, all the power to you. I, on the other hand, I'm good with typing it all out. But anyways, coming back to this, right? If we look at why this pod wasn't scheduled, warning, failed to create pod sandbox. And if we read in, we can see a bunch of things, and here we go. Network for pod busybox, network plugin CNI failed to set up pod busybox default, unable to allocate IP address. And the reason why that is because there's no CNI. So in the situation where you're actually running a kubeadm init and you haven't applied your CNI yet, what actually happens is if you take a look, these two core DNS pods will be in a pending state until you deploy a CNI. So you're going to have problems proceeding if you do not have this set up or going or up and running. And that's why you need the CNI up and running. Now I'm just going to go up arrow again a few times because I know I have it there, and I'm just going to change the delete to an apply. And it'll go ahead and deploy the Weave CNI. And when I go to check my pods again, get pods, I'll just watch it. Now, what's interesting is, I don't know why it went into a crash loop back off. Must be for a variety of other reasons. But if I just do a kubectl get pods, oh, okay, so it completed. So we're good. So the pod actually ran. It stopped running because I only set it to run for, I actually didn't specify any additional parameters for it to run beyond a few seconds. But what was interesting is it got its IP address. And I can show you if I run a kubectl get pods -oy. So look at that. It got its IP address, 10.44.0.4. Without the CNI, we wouldn't have that IP, and the BusyBox pod would not get scheduled, or the container would not get scheduled. There's a question here. Does the CKA touch on service mesh aspects with networking and multi-tenant? No, it does not. Service mesh is actually not a Kubernetes specific technology. It's a technology that sits on top of it and can be deployed in the sense that you would actually deploy something called sidecar containers alongside your main containers in a pod. Where you're going to see some service mesh like aspects is actually on the CKS, because the CKS talks about a lot of security, and in security, there's something called mutual TLS. In service mesh, actually, there's something called MTLS or mutual TLS. What happens is there is a certificate authority that is responsible for working with all the clusters, working with operators, and all the proxies or the sidecar proxies to receive a certificate and then rotate it. But that certificate, once you have it, automatically grants trusts or a trust or a mutual trust between all other service endpoints that are part of the Istio service mesh. It's not something you have to worry about for the CKA. It's something you would probably want to consider for the CKS, not specifically service mesh, but the MTLS piece. Okay, all right. So we've got the CNI up and running. We've looked at a bunch of networking things. We've seen the importance of having a CNI. One thing I'm just going to show you is how do you verify that a CNI exists, that a CNI is there. So if you remember, we're gonna just list out the contents of this directory, OPT CNI bin. And we can see in this directory here that we have the Weave IPAM and the Weave Net CNI as well as the plugin. So that means our CNI is ready to go, it's running. Another thing we want to look into is, no, it's not, it's CNI net, yeah, netd. Okay, so there's a file here for Weave, and if we cat that file, what it really just tells us is a very generic configuration of the fact that Weave is running, and it is the main CNI that is operable inside of the cluster. Now, this config can be expanded upon to add in IPAM, so you can go and customize the subnets you want inside of your CNI, much like you would in DHCP, and there's some other things you can do too. But I'll leave it at that with respect to CNI. I'll be honest, beyond that, the only thing to consider is that if you have a question on network policy, there is only one CNI that does not offer network policy today, and that is Flannel. I don't think it's going to affect you for the sake of the exam when you're bootstrapping, because you're probably not going to have a network policy question on this in the same question or in the same cluster as the same cluster you bootstrap Kubernetes onto. It'll probably be in a different cluster altogether. But just so you're aware, Flannel does not have the network policy capability. All right, so I'll come back to the demo environment. That's all I wanted to show you for CNI and networking considerations. Are there any questions before I flip to services?
And just the one that you addressed.
Okay, all right. Let's talk services. There's one more thing I wanted to bring up before I brought up services. Okay. Yeah, before I jump to services, there's just one little interesting tidbit I wanted to share with y'all. So if you go to the CKAD website, I'm actually going to paste this in the chat. This is a handbook which gives you a lot of great information around the exam environment and what to expect. I don't know if you've all seen this, maybe you have, but there was something very interesting that I noticed when I did my exam, right? If you look here, these are the clusters that are going to be available for you on the CKA. But if you look at this last cluster here, right? It's got a CNI called loopback. And that should be a big enough hint for you as to what to expect for that cluster there and what you're going to be doing there. In any case, I found that really interesting because there is actually no such thing as a loopback CNI. It's just effectively going to localhost or to a non-valid destination at this point. And so I would suspect that would be the cluster in which you're going to be bootstrapping Kubernetes and then installing a CNI. or it could be the cluster which has a bad set of IPs or something wrong with the kubelet, which is not allowing that node to be a part of the Kubernetes cluster. All right, let's move back to some more theory, and then I think what I'll have to do is no, how much time do we have? We have a lot more time, right?
Well, I mean, it depends. If you want to go an hour, then we've got,
Okay.
10 minutes left. If you want to, I mean, this is all good. This is all good information, and everybody's engaged in asking questions. So you can go longer if you want.
So here's what I'll do. Instead of using the presentation, let me reverse it, and I'll do some hands-on, and then I can come back next time we talk and cover off the services piece. I'll just quickly cover off one thing, and then I'll move into hands-on, and then we can wrap up for today.
The world is your oyster.
Thank you. All right. So there are really 3 types of services that you'll always encounter when it comes to Kubernetes. These services are there to basically facilitate access from external towards pod resources or towards pods that form your application. So for example, if I have a user that is coming from the external world to access an application, I will need to come in either through a node port or a load balancer. If I have internal apps that need to communicate with other internal apps, I might use cluster IP. So let's just briefly talk about this philosophically for a second, and then we'll move into some hands-on. So the cluster IP notion is really there to masquerade or hide any internal resource that does not need to be exposed. So you might have a backend database that your app that is exposed needs to write to, but that database itself never needs to be exposed. No one outside of that cluster ever needs to communicate with it for whatever reason. A perfect example of this is Core DNS. It's actually a database. It's a key value data store database, which is just holding a variety of data around DNS entries. And then you also have etcd, which is very similar of a database. But these elements do not need to be accessible outside of the cluster. So this is why they may be backed by something called cluster IP. And I'll talk a little bit more about the theory behind it next time we meet up again. But then there are some other services we need to be aware of, like I did mention, node port and load balancer. So when I need to communicate with an app, I need to come in and communicate through the node that that app resides on. So what that means is I'm using a port on the node, like we're talking about a TCP port on the node within the range of 30,000 to 32,500 or something like that. And that is going to translate to a pod resource, which is servicing our application. Now, the node port is tied to a single node. So if I have 3 nodes in my cluster, I'm using the node port service, I can always access my application through the node port. But where my challenge lies is what happens if I lose a host and then that IP changes. We'll talk about that like later on. And that's why we have the load balancer service, because I am basically now front-ending my node port service with a load balancer. So these 3 key elements tie into just how an application can be communicated with, and the way we would go about to just service our applications or access them, whether they're internal or external. But what I will do now is I'm actually gonna just pull up a GKE cluster because I wanted to point out something really interesting. If you were to deploy your own Kubernetes cluster, the documentation is pretty straightforward on how to just get it up and running. But beyond getting it up and running, you need a CNI, you need an ingress controller, you need a load balancer service, and a variety of other pieces to be fully functional. And so that's why, services or like as a service offerings like GKE or EKS or AKS or even TKG, are very valuable, because they shortcut the process of having to boot up a cluster. A lot of that's automated, and what you're left with at the end of the day is a Kubernetes cluster. And so right here, I have a bunch of GKE clusters, and what I'm attached to is something called the CKA cluster. And let's see if I am, oh no, I'm not connected. So let me quickly reconnect. And I probably have to go and open my thingamajiggy again. Yep. All right. So I just got to scroll over to the left here. Connect, running Cloud Shell. And if y'all are hearing that random babbling back there, that's my baby.
That's a tiny little adorable baby.
All right. Okay. So just so y'all know, I had a baby earlier this year, and he's the most wonderful thing ever that I've ever had to hold and deal with and play with. All right. So let's just verify some things here. kubectl get nodes. Okay. Here are.
Make that screen bigger.
Bigger. Okay. Let's go. Let's make it bigger. How do I do that? Terminal settings, font, text size, largest.
There you go.
Yeah, there we go. All right, we're rocking. Okay, so I've got my 3 nodes there, and let's see if we've got anything deployed to the environment. I've got one Nginx pod, and let's just verify if we've got namespaces here. So I've actually got another namespace called the Yelp namespace. Let's go check and see what's going on in that Yelp namespace there. So if I do a kubectl get all -n Yelp, get all just basically means I'm going to enumerate all the resources in the Yelp namespace. And lo and behold, we have a number of pods, a number of different services, and deployment and replica set. So the pods you're already familiar with. Deployments, I think you covered in one of the scheduling or one of the other sessions. I'm very certain about that, and even replica sets. The service is the interesting thing, right? The service is what allows us to take this. Okay, let's pick an example here. Let's take the Yelp DB, for example. So the Yelp DB pod right here has a label on it. It has a label which this service is looking at. So anytime a request comes in to communicate with this pod, it's going to hit this service on this IP right here on this port. But the service is looking for any pod that has a particular label match. And in our case, it's going to be this DB server. Now, the only time or the only person that's actually communicating with this DB server is likely the app server here, because it's writing some information to that DB server. So it is going to use, so we're talking about this app server here that's mapped to this service. It's going to use its service IP, which is here, to communicate with the database. We'll never see this app server communicate directly with the database server. Like, we're never going to see these 2 pods communicate directly to each other. And the reason why that is if I lost this pod, I still need another pod that provides the same level of function to come up online and still be mapped to this database server or service or this Yelp app server service, because it's like a proxy. I have a proxy in front of me that's going to continue to facilitate the communication. I just need that workload behind me to be present to answer those requests, but I'll facilitate it. I'll act as a proxy and facilitate that. And that's what cluster IP in this case is doing for us, right? But in the situation where we want to communicate with the application itself, right, we actually have something called the load balancer service right here. Now, when I instantiate a service of type load balancer, I'm actually calling on the Google Cloud load balancer in my case. There's actually to simplify, there's a trust between this Google Kubernetes engine cluster and the Google Cloud load balancer for us to provision load balancing resources. So when I specify I want a service of type load balancer, it's going to go call out the GCP LB and then give me an IP address. Now, once I have this IP address, I could take it and just plug it right into my web browser, and there we go. That's my app, right? Now, what's important about this is the GCP load balancer is the one servicing those particular requests on my behalf, on the behalf of the application. Now, if I decided, I wanted to just mess with things and change things up, so I could do this, right? -n Yelp. And what I'm doing is I'm editing a service, and I'm going to edit the Yelp UI service. And I'm now, in VI, I'm live editing a service entry. And you may have to do this in the exam too. I'm going to do the reverse. But what you may have to do is you may have to convert a node port into a load balancer. So what I would do is if I change this into node port, and I just delete this line. Okay, now I've changed the load balancer. I've changed the service type from load balancer to cluster, to node port. So if I, reran kubectl get service -n yelb, it's now node port, but I don't have an external IP. Now this is problematic for me. So how do I get to this actual app? Well, the way I would have to do it is I would have to assume a few things, right? I'd have to assume that my GCE instances that back my GKE cluster have ports open, specifically has this port open. If it's not, I'm messing with the GCP security groups or whatever they're called. I got to go look that up. But because of that, I can't even access this application anymore because now it's bound to the nodes themselves. So I need to know the public IP of those nodes, which means even if I ran, like, let's say if I did a kubectl get nodes -o wide, okay, I know the external IPs. Let's take an external IP here, right? Let's see if we can take this one. And I can't guarantee that it's going to work, but what we do is we'll pop it in there and see if it comes up. All right, and if it doesn't come up, the next step is we pop in, close this, I don't need that open. We pop in the port number here. So copy that, and then I'll add in the port number at the end because what we're accessing is an actual port on the node itself. And it's probably still not going to work. And the reason why that is because of the security groups of the firewall in Google Cloud's network. And that's expected, right? Because in the case of GKE and the load balancer that's being used, what's actually happening is a load balancer has firewall rules already applied to it, assuming that we're going to be accessing certain ports. See, it got blocked. It can't be reached. But effectively, if we didn't have that firewall in front of us, I could easily go to that application, but I'd have to use any one of those IPs. And as we already know, as I already mentioned, that's problematic. That's problematic because if any one of those nodes failed and we have to create a new node, it's not going to have the same IP. If it's not going to have the same IP, that probably messes with how we access that resource, especially if we've already created static entries for DNSA records across, or even like a CNAME alias or something along those lines. But what's important is you have, like, if you're thinking about exposing an application, you have access to that load balancer service. You're not limited. You can deploy GCP's load balancer. You can even deploy the Avi load balancer. You could deploy MetalLB for the sake of your own Kubernetes clusters if you want. But the idea is so that when you say you want a load balancer, the Kube API server is going to communicate with the load balancer provider and give you that load balancer when you need it. So just to make things clean again, if I go back in and edit this service, right, and I change this to load balancer. Before I exit, I'm just going to point out one more thing. You see this right here, the selector, app, Yelb UI, and tier front end. These are what map to the actual pod resources or the deployments. And I'm going to go reference this because this is actually what the service will look for as labels on the pod and deployment resources. If they are not there, this service cannot network for those pods, cannot accept incoming requests on behalf of those pods altogether. So remember those selectors. Let's get out of here and let's just do one last thing. kubectl get pods -a. -n yelb --show labels. And this command is very handy too, because it'll actually output all the different labels attached to any single pod resource. Now, if we go look at our Yelb UI, look at that. App equals Yelb UI and tier equals front end. These two labels are what the service look for in order to make sure that we can network to that Yelb pod or that Yelb UI pod. But that's how services work. In the next session for networking, what I plan to do is I've actually got some detailed information about this, which actually is more logical and has some diagrams, because what I need to also illustrate is where all these different components fit. Like where does the service come in? Where does the CNI come in? Like show me the layers, show me how this stack looks like in Kubernetes and even in the physical world. And I'll give you a little taste of it just so that you have an idea of what I'm referring to. Let's see, the balancer service, share screen. Okay. Let me know if you can see this, Chris, and everyone else.
I can see it now.
Perfect. Okay. So I'll review this again in their next session, but on the left there is a YAML file which defines a load balancer service. Normally, you don't have to specify the IP because we'll just go pull any IP. But if you specify it, the assumption is the IP does exist in the pool range, right? But if you specify a type of load balancer, it'll automatically go pull whatever IP it needs to. And as long as it has an annotation to go communicate with a, let's say, the Google Cloud Load Balancer or even, the AWS ELB, for example, then you will be good. But to give you context of the layers on the right side here, right, we have a pod. Then we have a pod that's wrapped by a replica set, but normally we don't deal with replica sets, we deal with deployments. So a pod is contained within a deployment. Now the deployment, once we've, deployed the YAML itself, then our app should be up and running, but we still can't network to it. And that's why we have that service. But what's important is that that service has a selector, like I just showed you, right? The labels that are existing on the pod and the deployment itself. Now that selector goes on the deployment and that gets automatically assigned to the pod. Now the service, whenever there's a request coming in for, let's say, website.com on port 30,080, it's going to hit the load balancer. The load balancer is going to translate that. It's going to translate that into one of these nodes behind that cluster. And then whichever node is, and we're round robining this at this point, right? So whichever node is free and available will respond to that request, but it'll then translate that all the way back down to this target port and this particular pod itself. It's a little bit more complicated than what I just described, but what I plan to do is on our next session, I'm going to actually step us through this in detail because I think it's important to really understand the difference between a target port, the port in the kube proxy, and the node port, because these terms can be very confusing and they can be so while you're doing the exam as well. So we'll spend some time clarifying where all of these are and where they're applicable as it relates to services in the exam. Okay, so there's a question here. Do the app and service need both labels to match, or would it work with a single map label? So it would work with a single map label, actually, as long as the service has a label and that it's looking for, and that same label is applied to the deployment. As long as it's there, it'll honor it and it'll network and proxy for it without a problem. Okay, so what I'm just going to quickly let you in on is next time we do meet up again, we're gonna touch on CNI again. We'll go deeper into services and we'll cover like core DNS and what we're going to have to do to manipulate that. But there's one really, I guess, I wouldn't say challenging, but pretty long section, and it's called ingress. And ingress is really for routing to different, I guess, backends of a single application. So the best example I can give is, let's say you have a website and that website has multiple web pages behind it. Now, if I had a single web page, that would just amount to a single pod. But if I have multiple web pages, I need multiple pods. I can't use a service definition to route to all those different pods uniquely to get to where I need to go. I need a service definition in addition to something called an ingress resource, because the ingress resource will allow me to route accordingly based off of any sort of backend that I append to my URL or my URL. If I have a specific URI, it'll route to that specific destination. If I don't, it may go to a generic destination. And that's where ingress becomes really important. We'll cover a lot of that next, I think on the, 27th, or I can't remember what day it is.
Oh man, you're calling me out. Hold on.
27th. It's on the 27th.
Is it? Okay.
Yeah.
Yeah, because you're skipping because your birthday.
Yeah, because my birthday's next week. And I wanted to actually not be stressed out about it, but
That's a legit reason. I'd have done the
but
same thing.
but yeah, I mean, these are, a lot of the stuff that I covered in this session today is really what you really need to focus on for the CKA. You're never going to have to worry about configuring BGP. You're never going to have to worry about route maps or anything of that fun stuff. It is worthwhile knowing your ports, though. Know what SSH port is, know what HTTP, HTTPS, DNS, which is UDP port 53. Those kinds of things are important to know because maybe they're blocked in the exam, and maybe you have to go and modify some firewall rules in the exam to make that possible. So, are there any other questions around CKA networking?
I don't see anything on the Twitter sphere, and no, I do like that you threw in that one last Facebook dig, though. That was nice. That was classy. No, we are good for questions.
Awesome. Awesome. I love it.
Cool. All right. Well, like Marino said, we will be reconvening for the networking part 2 at a later date. We've got the next episodes coming up. I'm not going to say any dates now because in the post recording, we're going to have, this is all going to, the people in the future, they're going to see this all in order. So we won't worry about that. So for those that are in the audience, though, pay attention to the schedule on the website and you will know what the deal is. Cool. Marino, thanks again for coming on, and we will see you again in 2 weeks.
Awesome. Thank you so much, Chris. And thank you everyone for your time tonight. It was a pleasure.
Cool. All right. See everybody next week. And